Okay, problem 8-89. When it says create your own polydoku puzzle, that just means, polydoku, whatever, that just means long division. So we are gonna set up a long division table. When I set mine up, I leave them never ending, because when you first get started, sometimes it's hard to know how long it should be. So I set mine up and I start drawing some boxes, but then I just leave it kind of open at the end. So I'm doing A. 3x minus 1 goes on the left. Remember that first term goes inside your first box, so 6x to the fourth. And then it's an area diagram. The left, 3x, times the top has to equal 6x to the fourth. So this must be 2x cubed. Then you do the top times the bottom left, negative 2x cubed. Then the diagonal is supposed to equal the next number on the top. So I need it to equal negative 5x cubed. I have negative 2x cubed, so minus 3x cubed would give me negative 5x cubed. The left, 3x times the top, must be minus x squared, has to equal that box. Bottom left times the top, x squared. That diagonal has to equal the next number, 10x squared. So I have x squared, so 9x squared more. The left, 3x, times the top, must be 3x. The bottom left times the top. The next diagonal is supposed to equal the next number, negative 18. So I have negative 3 now, so negative 15x. The left, 3x, times, this must be minus 5. The bottom left times the top. It happens to equal the last number that you see there. That is 5. So the answer to A is 2x cubed minus x squared plus 3x minus 5, if it was just asking you to divide. But then it does say write a multiplication and division statement. So that's what my division problem equals, A. But then I also know that 3x minus 1 times that number, or polynomial I should say, would equal the top. I'm going to go down below so I have space. Would equal the big polynomial that we were dividing to begin with. But the orange box is the answer. That's what I want you to focus on. Okay, so maybe set up B and see if you can do B on your own, but I'm here and I will keep working on it. Again, I set up never ending because I don't know if I'm going to have a remainder or not. I don't know how many boxes it needs. I am dividing by x minus 2. Notice this problem is missing a term. There is 0x squared. That's going to be super important when we start our division. So first term in the first box. Left times the top has to equal that, so it must be x cubed. Bottom left times the top. That diagonal is supposed to equal the next number. I have negative 2 now, so I need negative 4 more. Left times the top. Bottom left times the top. That next diagonal is supposed to equal the next term. Remember, this is where that 0x squared comes into play. So if I have 8x squared, I need negative 8x squared to make that become 0. The left times the top. The bottom left times the top. The next diagonal is supposed to equal the next term. I have 16, so I need 2 more. The left times the top, so this must be 2. Bottom left times the top happens to be negative 4, which is the last number of the polynomial. So the answer to the division problem is the top. If I wanted to write it as a multiplication statement, I know the left edge times the top edge of our area diagram, would equal the top polynomial that we divided by at the beginning. Okay, I'm going to need to start a new page to do C and D. See what you can do with C and D. Okay, so here's problem C. Set up an area diagram. It's all the same, right? We're doing long division. You divide by the one on the left, the way this one's written. X minus 3. Make sure you see every exponent. Cubed, squared. Sorry about that. Make sure you see every exponent on the inside. X cubed, x squared, x constant. So first term goes in the first box. Left times the top has to equal that. So the top needs to be x squared. Bottom left times the top. The next diagonal is supposed to equal the next number. So negative 3x squared. I need it to be positive x squared, so I need 4x squared. The left times the top. Bottom left times the top. Next diagonal is supposed to equal the next number. Negative 12, so I need negative 2x. Left times the top. Bottom left times the top. This time it does not equal the next diagonal. Sorry, the next diagonal does not equal the constant. So I do need a remainder. I need it to be minus 3, so that 6 minus 3 gives me the positive 3 in the question. And now my answer is x squared plus 4x minus 2 minus 3 over x minus 3, because this problem has a remainder. I'm going to stop right there. D has a lot of missing terms. D should say x to the 5th plus 0x to the 4th plus 0x cubed plus 0x squared plus 0x minus 1 all over x minus 1. So long division. We're dividing by x minus 1. First term in the first box, x to the 5th, so you'd have to multiply by x to the 4th. Bottom left times the top. I need this diagonal to zero out because I should have 0 of them when I'm done. So I need positive x to the 4th. Left times the top. Bottom left times the top. That diagonal needs to zero out as well because I have 0x cubed. So positive x cubed. Left times the top. Bottom left times the top. That diagonal, you should be catching on, also needs to zero out because I have 0x squareds. So positive x squared, left times the top. Bottom left times the top. That diagonal needs to zero out as well. Left times the top. Multiply, and I do get the constant that they have at the end. So the answer is the top. X to the 4th plus x cubed plus x squared plus x plus 1 is what I get when I divide. Okay, 8-91. It is telling us to do the division. So if you read through that carefully, I mean right here, you're doing p of x divided by d of x. So for number, or a, I guess, we're going to do x minus 11 into the 2x cubed, etc. So 2x cubed. You should be getting a little better at this. I'm not going to talk through every single step I do. So this diagonal is supposed to give me negative 21. So I need to add I need to add an x. So an x squared. Forgot my squareds. This diagonal is supposed to give me negative 9, so I need to add 2x. That is not 30, negative 30, and I need it to be, so I need minus 8. So then the answer to A is 2x squared plus x plus 2 minus 8 over x minus 11. Remember, you put your remainder over what you divided by. Then C, B. I'm going to do B down below. We're dividing x plus 2 into 3x to the 4th. That would have to be 3x cubed. 6x cubed needs to make 5, so minus x cubed minus x squared minus 2x squared needs to make, oh, there's a 0x squared in here. Needs to make 0, so 2x squared, 2x, 4x. Needs to make negative 4, so minus 8x, minus 8, negative 16, which is not the constant. So I need a remainder. I need a positive 3 to be my constant, so my remainder needs to be 19. So long division for B ends up equaling 3x cubed minus x squared plus 2x minus 8 plus 19 over x plus 2. Now, they want you to use P of 1 and plug in 11. So I'm back up at the top. I'm using this equation and I'm plugging in 11. You're going to need a calculator. Go ahead and see if you can do that. Plug in 11. Grab a calculator and see what you get. If you're really careful, you should get an answer of negative 8 when you solve that. And you should notice our remainder was negative 8 earlier. What are we on? Part D. They want you to plug negative 2 into this polynomial. So carefully plug in negative 2. And see what you get. If you carefully do that math, you should get an answer of 19, and you should notice and remember that our remainder was 19. So the remainder theorem tells you if I was dividing by x minus 11, my remainder is going to be the same thing as if I plugged in x equals 11. If I'm dividing by x plus 2, my remainder is the same thing as if I plugged in x equals negative 2. So that's what this problem was trying to show you. Hopefully that helps.